Alright, so this is going to cover everything that we've learned in lesson 1, everything that we've learned about mixtures and solutions so far. Okay? So number 1 says a 5th grade student was showing her little brother what she was learning in science class. She mixed 20 grams of white powder in 80 milliliters of warm water, and the water stayed clear. Her brother said, "Wow, that's magic. The white powder is gone." Draw and label a model to show what happened to the white powder when it was mixed with the warm water. Was the powder really gone? No. What happened?
It dissolved.
It dissolved. Okay, so it dissolved in the water. Looked like it was gone, but it was really still there. So we're going to draw a little before and after picture. I'm not a great drawer, so y'all just bear with me. Okay? So this is going to be our before cup, and this is going to be our after cup. Okay, we've got water in here. We've got water in here. Let's draw a little spoon with some powder going into the water. Okay. Anybody remember what the 2 parts of a solution are? Anybody remember those words? Hunter, you remember? Let's start with S.
The solute and the solvent.
Good. Solute and solvent. So in this case, our solute would be the powder, and our solvent would be the water. Okay? So this is our warm water. This is our powder. We're putting the powder into the water. And then our powder fully dissolves, so it just looks like water in here. Okay? So when the powder dissolves, it looks like just water, because a solution, a property of a solution is that it has to be transparent, meaning you can see through it. Yes? Okay. So the material's still there, you really can't see it, but it still has mass. And you could still use the evaporation process to get the powder back out of the water, kind of like we did with the salt. Okay, B part says, what is the weight or mass of the white powder in the water mixture? Show your math in the space below the line. Okay, so when you're making a solution, the water has mass and the material has mass. So think back to when we did the scale and we measured 50 milliliters of water equaled 50 grams of water. Remember that? And then we added the salt to it, and that also added mass to the water because the salt had mass. So basically, any solution is equal to the sum of its parts. So, if you look back up in the problem, how much white powder was added? 20 grams. And how much water was there? 80 milliliters. So we know that would equal 80 grams. So, what would be the total weight or mass of the solution? Good. Right, that helps you out on B part. So the 20 grams of powder plus the 80 grams of water would equal 100 grams of the solution. written on the first page, you can flip over to number 2 on the back. Alright, number 2 says, a family lived near a saltwater bay. At the edge of the water, a child scooped up a bucket of salt water that also had pebbles, sand, and silt. I wonder, another child said, how you can separate all the different materials in that bucket. Describe a method that would separate all the different particles and explain why that method would work. So we did this Friday. Remember Friday you had to write down your procedure and your steps in your notebook? And then you had to carry out those procedures to see if you were able to separate everything, okay? So it tells us this is salt water. It's also got pebbles, which would be like the gravel. It's got sand, which would kind of be like the powder. And it's got silt, which is basically like dirt. Silt is like dirt. So the salt and the silt are going to be very similar as far as particle size. And so we've got to figure out steps to get all of that separated. The pebbles, the sand, the silt, and the salt water. So, Hunter, what would you start with? What tool would you use first?
The screen.
Okay. Alright, and what's the screen going to do?
It's gonna separate the pebbles from the water.
Good. So first we're going to use the screen to separate pebbles. Good job. Alright, so think back to Friday, after we use the screen, and we don't have anything magnetic in this mixture like we did on Friday. So after we use the screen, Sabin, what did we use next? The filter, good. And what's the filter gonna get out? Okay, and in this one we don't have powder, but we do have sand and silt. So the filter is gonna help us separate the sand and the silt. Okay, so we've got pebbles out, we've got sand and silt out, we just gotta get the salt water out. What are we gonna use, Alea?
We are going to use evaporation.
Evaporation dish, good.
Miss Bishop,
Mhm.
are you gonna get the salt in the water? Basically? If we get the salt in the...
Yes, the water will evaporate, so all we should be left with is salt after a few days, a week or so. Alright, the last part of that says explain why this method would work. So let's think back to the very first time we tried to separate a mixture. Why wasn't the screen able to separate the powder and the salt? It did separate the gravel, but it didn't separate the powder and the salt. Why? Alyssa?
Because the powder and salt are small, so it will go straight through the screen.
Good. The particles are small, right? So we know this method would work because the sand and the silt would not be able to be separated by the screen because the particles are too small, okay? So we use the tools in the order that we did based off the size of the particles. Right, number 3, a cook mixed a tablespoon of powdery brown spice into a glass of warm water. After a few minutes, she observed the liquid in the glass. Which observation below would provide the evidence that the mixture she made was a solution? Okay, so let's review the properties for a solution, okay? The material has to be dissolved, okay? It has has to be transparent, meaning you can see through it. Right? So with that in mind, let's look at our answer choices. A, the liquid turned a cloudy brown with nothing on the bottom of the glass. B, the liquid turned a clear brown with nothing on the bottom of the glass. C, the liquid remained colorless with brown powder on the bottom of the glass. Or D, the liquid turned a cloudy brown with some powder on the bottom of the glass. So if it's a solution, are you going to have anything left at the bottom of the glass?
No.
No. So what does that eliminate? No. A says nothing on the bottom of the glass. C and D. Use your test taking strategies. Okay, so we're eliminating C and D. A says it turned a cloudy brown. B says it turned a clear brown.
Clear brown.
Clear brown because it has to be transparent. Fill in that answer choice and flip over to number 4. Right, number 4 says salt can be purchased in 2 grain sizes, small grain table salt and large grain kosher salt. A student mixed 10 grams of each kind of salt in 2 different containers of water. Each solution was heated on a hot plate to speed evaporation. And they kind of give you a little diagram or picture here. Both of these have 90 grams of water. This one is 10 grams of large grain. This one is 10 grams of small grain. And then they heated both on the hot plate. So it says which statement describes what will be left in each cup after the water evaporates. Okay? So we talked about earlier, we put 5 milliliters of salt into our saltwater solution and then evaporated that saltwater solution out. And how much did I say, how much salt was still there? Still 5, okay? So the mass of the salt doesn't change. Keep that in mind. So are we going to have 0 grams of the salt?
No.
Does it disappear, poof, it's gone? No. So you can eliminate A, okay? And if we put 10 grams of small grain and 10 grams of large grain in, and it doesn't go anywhere, you're still going to have the same amount when it's evaporated, right? So which one of these answer choices makes sense?
D.
Right, we talked about number 5 already. Knowing the particle size of the materials in a mixture helps you know what?
Which tools to use?
Which tools to use. We had to do that when we wrote our procedures down, okay? So knowing that particle size helps you know, do I need to use a stream? Do I need to use a filter? Do I need to use evaporation? Those kind of things. Alright, number 6, the student made a mixture of tiny black iron fillings, black salt, black sand, and water in a glass. At first the mixture was cloudy. After 20 minutes the water was clear and black, and there were black particles on the bottom of the glass. Which statement is true given the information above? Okay. A says the liquid is a solution because the water was cloudy with black particles. Is it going to be cloudy if it's a solution?
No.
No. Eliminate. B, the liquid was a solution because the water was black and clear. Maybe, but let's read our next 2 answer choices just to make sure. C, the liquid was a solution because the iron fillings and black sand were completely mixed.
No.
They weren't completely mixed because there was still some on the bottom. So eliminate C. D says the liquid solution was a solution because there were particles on the bottom. No. So which is the best choice?
D.
Good. Uh-huh. On number 4? Page 4 or number 4? Number 6? It helps you know what tools to use. Alright, at the bottom it says the student wants to separate the mixture so each material is in its own cup. The steps to separate the mixture are given below in no particular order. Write a number, 1, 2, etc. on each line to indicate the order of steps. If a step is not needed, leave the line blank. There is one of these steps you will not use. Okay? So this is the sand. It's hard to see on your copy, but this one on the left is sand. This is the iron, and this is the salt. Okay? So think back to Friday. And what did we say would be the smartest thing to use first? Some of us did it, some of us didn't. Cooper?
Magnet.
The magnet, good. Alright, so I'll probably use the magnet first, so that's going to get the iron. Okay, next we'll probably want to try to separate the sand, so what will we use, Kay?
The filter
The
paper.
filter, good. And then you're probably going to want to get the salt out, so you're going to use what, Zaviana?
Or the mixture between those two.
Evaporation, okay? Are we going to need the screen?
No.
No, we don't have any gravel or pebbles this time, so we'll leave that one blank. Alright, and you've got that, you can flip over to number 7. So citric acid is a solid that dissolves in water. It makes the water taste sour. A solution of citric acid in water was poured through a filter. Which sentence best predicts the taste of the solution after filtering? Okay. Well, we tried pouring the saltwater solution through a filter. Did it do anything? No, because those salt particles are small enough that they just go right through the filter. So citric acid, if it's a solution, those salt particles are dissolved into the water. So it's just going to go straight through that filter just like the saltwater solution did. So is that going to change the taste?
No.
No, it's still going to taste the same that it would have before. Go ahead and bubble in your answer for number 7. And last one, number 8. Tea bags are small bags of filter paper filled with tea leaves. You make tea by placing the tea bag into hot water and letting it sit for a few minutes. Explain how the color and taste of the tea get out of the tea bag and into the hot water, while the leaves stay in the filter paper. Alright, has anybody ever made tea before? Helped your mom or grandmother or somebody make tea? Okay, so once you get those tea bags into that hot water, you can start to smell and also see the water turning brown, right? So what's happening with the tea bag? Alea?
And the filter paper has this microscopic hole in it.
Mhm.
It allows the tea bag to suck the black stuff and suck the leaves get out of it. But the leaves will stay in there because the leaves are more bigger than the microscopic.
Perfect. Yeah, the tea bag acts as a filter. And that allows the flavor or the flavor and the color of the leaves to escape. But not the tea leaves. Because those tea leaves are going to be too big to pass through those microscopic holes. Alright, when you're done, just double check that you got your name on it and you'll hold it up. I'll come by and pick it up for you. And we got one more thing we need to do. Okay, fold it back over. Fold it to the front. different places with these online tutorials, so you might have to go. Molly, Kate, can you turn that light down for us?